Okay, so use the intermediate value theorem and your calculator to find intervals of length 1 in which the function is guaranteed to have a 0. So put this function in the calculator, and you can see same thing. So at that point, graph. And because I'm zoomed in, let me zoom out again. Zoom 6. Okay, so where do we see, how many zeros do we see first of all? There's 1, 2, 3, and 4. And just looking at the graph, I would think that that is 1, 2, 3. That's between -4 and -3, between -1 and 0, between 0 and -1, and between 3 and 4. I think the way they did it in the book is first they just seemed like they estimated from the graph, and then later they looked in the table of values. So we would right away, we could say, here's our intervals. -4, -3, right? That's an interval now, not a point. -1, 0, 0, 1, and 3, 4. Okay, why is it guaranteed to have a 0 in between those two? Because it changes sign and because polynomials have continuous graphs. There's no way they could like jump over the x-axis. Okay, now we could confirm that by looking at the table of values. And let's go down. So between -4 and -3, it changes sign. Between -1 and 0, it changes sign. Between 0 and 1, it changes sign. And last, between 3 and 4, it changes sign. Right? So by intermediate value theorem, and because polynomials are continuous, we know there's a 0 in there. Now, the exercise of actually finding the 0, I think we just went through that, so I won't add that.